Chapter 6 has a lot of stuff about different kinds of segments within triangles. So perpendicular bisectors, angle bisectors. We're going to learn about something called medians and altitudes. We'll do that next week. We're going to do the first 3 sections and then pause for a quiz next Thursday. So we'll do 6-1, 6-2, 6-3, review, and then quiz. And then test is like the following week on chapter 6. So we start with perpendicular and angle bisectors. These are both things we already know, but now we're going to learn some theorems about them and then apply them to like a graph. So the first one is the definition of the perpendicular bisector, which again, think about the name of it, perpendicular and bisector. The perpendicular part says it has to meet another line or segment at a right angle, and then the bisector is it has to cut that segment into 2 congruent parts. So it hits it at its midpoint. You can only perpendicular bisect a segment because it has to end. But the actual bisector can be a line, a ray, a segment, or a plane because it can stop. It doesn't have to. But obviously the one you're bisecting has to be a segment. And then you're going to see the word equidistant a lot today in some theorems, and that means same distance. Okay? So by definition, it hits it at its midpoint, cuts it into 2 congruent parts, and you'll have a right angle there, or perpendicular lines. And then equidistant means same distance. The perpendicular bisector theorem, which obviously has a name, you can use it, or you can write it out if you don't remember. But it says in a plane, if a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. So in this diagram, you've got a segment, which is AB. And then you've got the perpendicular bisector to it, which is CP. And again, that could be a ray, a line. It could have been a plane too, but for this theorem, it has to be the line. Well, it can't be a plane, but it can be a line segment, a ray. And what it says is that any point on that bisector would be equidistant from the endpoints of the one that's being bisected. So if you have a diagram drawn like this, then I would know that CA and CB are congruent because C is equidistant from the endpoints of that bisected segment. So if I put a point on the other side, like let's say I just plotted a point over here, and I call it M, M would also be equidistant from B and A. So AM and MB would also be congruent because M lies on the perpendicular bisector of the segment. So any point from there is going to be equidistant from the endpoints. The converse of that, remember converse says flip the order, says in a plane, if a point is equidistant from the endpoints, then it lies on the perpendicular bisector of that segment. So if I have a point, again, above, below, doesn't matter, but in this case, like D, and it is equidistant from the endpoints of a segment, like A and B here, and I know it's equidistant because they're both marked as congruent, then I can say that D lies on the perpendicular bisector of that segment. Specifically in this one, I could say that D lies on line CP or ray CP because CP, line CP or ray CP, is the perpendicular bisector of that, of AB. So first one says if it's on the bisector, it's equidistant. This one says if it's equidistant, then it's on the bisector. All right, and then this is one of the ways you'll see it. It says BD is the perpendicular bisector of AC, and that's important because it's not marked in the picture. So BD is the perpendicular bisector of, what does it give you? AC, which means it meets it at a right angle and it cuts it into 2 congruent segments. And then it wants you to find AD. Well, since D lies on this, DC would be congruent to DA. So I can say 3x plus 14 equals 5x. And then subtract the 3x. 14 equals 2x. And then divide both sides by 2. And x equals 7. There's a lot of setting 2 things equal to each other in today's stuff. which means there's work, which means homework, you're showing work. Okay, you might also see it written opposite. It might say what value of x would make BD the perpendicular bisector, and you'd still do the same thing. In order for it to be on the perpendicular bisector, it would have to be equidistant from the endpoints, and so you'd set it equal to each other. Good job, I was just making sure you're paying attention. Okay, it doesn't ask for x, it asks you to find AD. So now I gotta plug that x back in. 5 times 7 is 35. Thank you very much. All right, example 2. Oh, sorry. Okay, it says use the diagram and the given information to find the indicated measure. Number 1 says ZX, which is this vertical line here, is the perpendicular bisector of Y or WY, which means it cuts it into 2 congruent parts, and it's a right angle, which it's already that part's already marked. YZ is 13.75. Find WZ. What is it? 13.75. Second one is separate from that one, so it starts the same way. It says it's the perpendicular bisector. Then it says WZ equals 4n minus 13, and YZ equals n plus 17, and it wants you to find YZ. How do I do it? Good. So 4n minus 13 equals n plus 17. Subtract the n. 3n minus 13 equals 17. All right, we're going to add the 13. 3n equals 30. Divide by 3, and n is 10. And it's not asking for n, it's asking for yz. So I'm going to take what yz equals, which is n plus 17, and plug it in. And honestly, it wouldn't have mattered which segment you plugged that 10 into, whether you did the 4 times 10 minus the 13 or the 10 plus 17. They should give you the same answer, and that's a good way to check to make sure that you did it correctly. Questions on that one? Okay, then it says find WX. Erase all this stuff up. Find WX when WZ is 20.5 and WY is 14. Wait, I just labeled the wrong one. This is what we're looking for. WY is 14.8 and YZ is 20.5. Why is it giving you all that information?
To trick you.
No. Yeah.
So that you know that both angles on the outside are congruent, which means that the two angles.
So I don't need to know about the angles, but this time notice the difference between 1, 2, and 3. They didn't tell me anything about it being a perpendicular bisector yet, right? So I have to determine it's a perpendicular bisector. How do you determine it's a perpendicular bisector? Good. These are the same, which means Z lies on the perpendicular bisector of that bottom segment. And if that's the case, it cuts it into 2 congruent parts, which means X would be 1/2 of 14.8, which is 7.4. So they didn't tell you it was the perpendicular bisector that way this time. The way they do that is by giving you that those outside lines or segments are congruent. If that's the case, then it's the perpendicular bisector, which means it cuts it into 2 congruent parts. Questions on that one? All right, now we get into the second special type of segment, and that is an angle bisector. If a point is on the bisector of an angle, or sorry, this is a theorem. We know what the definition is. If a point is on the bisector of an angle, then it's equidistant from the 2 sides of the angle. So by definition, an angle bisector is usually a ray, but it could also be a segment that cuts an angle into 2 congruent parts. And the theorem is telling us that if a point is on that angle bisector, then it's equidistant from the sides. So 2 really important things here. One is it has to tell you it's the bisector, or these little marks have to be here. If those two congruency marks are there, then I know AD is the bisector of the angle. So you have to have that information one way or the other. It's either going to be like in the instructions, AD bisects angle BAC, or it will be marked like that. If that's the case, then any point that's on here, so in this example specifically, D is the point that's on that angle bisector, is equidistant from the sides. Now the way you show true distance is a perpendicular segment. So that's the second thing that's super important. These have to be right angles. I can't just draw an angle bisector, and then plot a point and say this is congruent to this. It has to have a right angle. So it has to connect to the side of the angle at a right angle, okay? In order for you to know that those two are equidistant or those two segments would be congruent. So D is equidistant from the sides, making DB and DC congruent. Like the perpendicular bisector theorem, there's a converse to it, so flip-flop it. If a point is in the interior of an angle, so it has to be in between the sides of the angle, and it's equidistant from the sides of the angle, then it lies on the bisector of the angle. So we flip-flop the if and then. Looking at this diagram, D is equidistant from B and C, so it's equidistant from the sides of the angle, which means D lies on the angle bisector, which means these two angles are congruent. So the if this time is that it's equidistant, the then is that it's on the angle bisector. The flip-flop of the last one. And again, it would be helpful to know that name so that you can use it. Converse of the angle bisector theorem, or angle bisector theorem converse. I don't care where you say it, but it's got to be said somewhere. All right. Find the value of x. What do I know about the ray inside that angle? What's this called? An angle bisector. And I know that because these are both 20. So if it's a bisector of an angle, any point that's on here would be equidistant. It has to have the little right angle marks. And then all I have to do is say x equals 15.
Easy peasy.
Yup.
So if that was on the homework, we wanted to show work for that.
Correct. Now this is the reverse. I don't know the angles are congruent yet, but what I do know is that the segments that are perpendicular, which means it's showing that they're equidistant. If it's equidistant, it's the angle bisector, which means
They have to be equal.
good. 3x plus 5 equals 4x minus 6. Is that a 6? Yeah, I think so. And then subtract the 3x. 5 equals x minus 6, and then add the 6. And x equals 11. And again, the wording on that could also say what value of x, instead of it being like congruent, what value of x would make that an angle bisector. Could be something like that. Yep.
What is the equation that I tried? I can't tell.
If it's what?
Like, what are those two equations for the
This is this angle, and this is this angle. Yeah, it is kind of hard.
Oh, it's angles. I thought.
There, well, that's why the degree symbol is there.
Oh.
I thought it was talking about the perpendicular ones.
Yeah,
That
no.
doesn't make sense.
Nope, that wouldn't make any sense. No. All right, again, this time what information is already given? Is this the original theorem or the converse?
The original.
Original, because it tells you that it's an angle bisector. So then we know this angles are, or the segments are congruent. 5x equals 6x minus 5. Subtract the 6x. And x equals 5. So it's important to distinguish the difference, because if it said explain why, or what theorem allows you to prove that, this is the original theorem, the angle bisector theorem, whereas the last one we just used would have been the converse. Good so far? No. No. Now we get this one, and yours is an answer on it, so feel free to ignore it, because obviously that wouldn't have been given to you.
Oh.
Yep. So this is bringing back in the algebra of the equations of the line. So this says write an equation of the perpendicular bisector of the segment with the endpoints of -2, 3, and 4, 1. So if this was given to you on a quiz, you wouldn't have even plotted that point. So I could give you the graph, you have to plot the graph, that kind of stuff, okay? And obviously the answer definitely wouldn't be there, okay? But if I had plotted it, I would have gotten that P was -2, 3, and Q is 4, 1. And I would have drawn that segment. Now, in order to find the perpendicular bisector of that segment, what two things do I have to have about a perpendicular bisector?
That both sides are congruent.
Which tells you you need to know what the midpoint is, right? So I have to find the midpoint of this segment. And what else? What's the perpendicular part? The opposite reciprocal of the slope of this line. So I'm going to find the slope of this line and then use the opposite reciprocal. Then I have a point and I have slope and I can plug it into an equation, okay? So the first thing I'm going to do is find the midpoint using these two. Do you remember the midpoint formula?
Yeah, but you can kind of see it here.
Yeah, but how would you have gotten it?
x1 plus x2 divided by 2, y1 plus y2 divided by 2.
Good. Add the 2x's divided by 2. Add the 2y's divided by 2. So I'd get 2 over 2, which is 1, and 4 over 2, which is 2. That's the midpoint.
No, but like, you could kind of see it in the segment. Like even if you didn't, like you could just see it's right there.
But I told you you'd have to graph it. Like you wouldn't be given that. Yeah, okay. And then I need to know the slope of the blue line because that's going to give me the slope of the opposite reciprocal of that's going to give me the slope of the other line. How do I find slope?
You have to count the rise of the.
You can count the rise over the run, but if you don't have a graph, y2 minus y1 over x2 minus x1. So 1 minus 3 over 4 minus a -2 is -2 over 6 or -1/3. Now that's the slope of my original segment. So what's the slope of the perpendicular bisector?
Wait.
My original slope is this. What would be the slope of a line perpendicular to it? +3. Flip it, change the sign. Now I need to find the equation of a line with those two pieces of information. So you can either plug it into y equals mx plus b, or you can plug it into point slope because that's what you have. Y minus y1 equals m times x minus x1. So y minus 2 equals 3 times x minus 1. Y minus 2 would equal 3x minus 3. Add the 2. And y equals 3x minus 1.
How do you do it in slope intercept?
You plug in the x and the y and the m. So I'd get 2 equals 3 times 1 plus b. 2 equals 3 plus b. Subtract the 3. B is -1. And then you plug back in the slope and the b.
Wait, where do you get 2 from?
This is your x and that's your y. The midpoint, the coordinate of the midpoint.
Oh.
So you got to find the midpoint. You got to find the slope and then use the opposite reciprocal. And then you find the equation. And you need to be able to do that without a graph. Yeah, Jonathan. I know, I said that already. I know, yes, but obviously on a quiz or a test, it wouldn't be there. Questions? So this is another chapter where I would say a Quizlet's going to help because we're going to start to add more segments. Like we start with angle bisector and perpendicular bisector, and they each have a theorem. Well, they each have 2 theorems. So I will start, like by the time quiz rolls around, I'll release a Quizlet that has all the stuff from at least 6-1, 6-2, 6-3, and then obviously we add to it later. Okay. Everybody's good? Yes? Okay. Homework's on big ideas. You've got 20 minutes. You could probably finish it.